This is Chapter 10, Set A. It tells us we have a certain class. We have midterm scores that have an average of 60 and SD of 15. And this problem is very confusing because it says the final scores are exactly the same. Kind of a pain. The correlation between the midterm scores and final scores is about 0.5. Let's estimate the average final score for students who have these different midterm scores. Okay. When I look at this, the thing that tells me this is going from Chapter 10 is that we have two different variables, basically. We're talking about midterm scores and final scores. Now, I always start by writing down the information it tells me. So for my midterm, I have an average of 60 and SD of 15. And then it said for the final, it's actually the same values. So they're going to have an average of 60 and SD of 15. And then it also tells me my correlation is 0.5. So once I have that written down, now I can go through. Let's see, let's estimate the average final score for students whose midterm scores were, etc. So I'm trying to estimate the final, so that's going to be my y variables. I like to label them. And then midterm will have to be my x. So whatever you want to predict has to be your y. Okay. So doing regression this way is much more complicated because we're not using formulas. They're trying to get you to use logic. In Chapter 12, we're going to learn a new way to do it that just uses formulas. I feel like it's so much simpler. Okay, but for what we're doing right now, because that's what's on your first exam, okay, is using our logic. So when we go through, the steps we're going to do is we're going to say how many standard deviations is the x value from its average. So when we're on this step, all the numbers we use have to come from the x's. So to find the z value for x's, to find a z value always tells you how many standard deviations you are from an average, no matter what chapter you're working in or what you're doing. If you do an x minus the average over standard deviation, that's how many standard deviations you are from your average. So in our case, let's do part A. Let's do 75. So we'll do 75 minus the average of the x's. Make sure you're doing average of the x's because we're talking about x's on this step. Divide by the standard deviation of the x's, which gives me 15. So this should be, I think, what, 1? So it gives me 1. Step 2, we're going to multiply z times r. So z is what we just barely found. So we're going to do that times our correlation of 0.5. So 1 times 0.5 gives me 0.5. So now this value right here is the number of standard deviations the y value is from its average. So basically on this point, we're just reversing the y formula. So remember how we did this, sorry, the z formula, how we did this in Chapter 5? If z equals x minus the average over standard deviations, then we can just kind of rearrange that, like we're solving an equation, and we get it's going to be the average plus something times the number of standard deviations. Now normally you put just a z there, but we can't do z in this because remember we had to multiply z times r. So it's going to be that z times r that you found in step 2. The reason we don't just write this out as a formula is you might be confused, like, well, where was that z supposed to come from? Or what averages were you supposed to use? Things like that. And so they were trying to get you to do by logic instead of teaching you formulas. But we're basically just reversing it. We're saying, well, if it's how many standard deviations you are from the average, you'll just do the average plus that many standard deviations. So in our case, we'll do y equals average, but you have to do all the y numbers now. So we'll do 60 plus z times r, which was this 0.5, times the standard deviation of y, which is 15. So this should give me, oops, 67.5. So that's my prediction. It may or may not be right, but remember we said the reason we multiply z times r is our predictions ended up being more accurate more often. Okay. So as we go through the steps, first we find z using all of our x values. Then we times it by our correlation to get our better predictions. Okay. And that tells you how many standard deviations your y value should be from its average. So you'll do the y average plus however many standard deviations. And that's what we're going to do. We're going to just repeat that over and over for each of these values. So now you'll do it for 30 and you'll do it for 60. Just do the exact same thing.